The Palouse is a region of the northwestern United States, encompassing parts of southeastern Washington, north-central Idaho and, by some definitions, parts of northeast Oregon. It is a major agricultural area, primarily producing wheat and legumes. Situated about 160 miles north of the Oregon Trail, the region experienced rapid growth in the late 19th century, and the population of the Palouse once surpassed even that of the Puget Sound area as Washington's most populous region. It is home to two land-grant universities, the University of Idaho in Moscow and Washington State University in Pullman, just 8 miles apart. Both schools opened in the early 1890s. Geography and history. The origin of the name Palouse is unclear. One theory is that the name of the Palouse tribe was converted by French-Canadian fur traders to the more familiar French word Palouse, meaning land with short and thick grass or lawn. Over time, the spelling changed to Palouse. Another theory is that the region's name came from the French word and was later applied to its indigenous inhabitants. Traditionally, the Palouse region was defined as the fertile hills and prairies north of the Snake River, which separated it from Walla Walla County, and north of the Clearwater River, which separated it from the Camas Prairie, extending north along the Washington and Idaho border, south of Spokane, centered on the Palouse River. This region underwent a settlement and wheat-growing boom during the 1880s, part of a larger process of growing wheat in southeast Washington, originally pioneered in Walla Walla County south of the Snake River. While this definition of the Palouse remains common today, the term is sometimes used to refer to the entire wheat-growing region, including Walla Walla County, the Camas Prairie of Idaho, the Big Bend region of the Central Columbia River Plateau, and other smaller agricultural districts such as Assateague County, Washington, and Umatilla County, Oregon. This larger definition is used by organizations such as the Worldwide Fund for Nature, who define the Palouse grasslands ecoregion broadly. The community of Palouse, Washington, is located in Whitman County, about 7 miles west of Potlatch, Idaho. Nevertheless, the traditional definition of the Palouse region is distinct from the older Walla Walla region south of the Snake River, where dryland farming of wheat was first proved viable in the region in the 1860s. During the 1870s, the Walla Walla region was rapidly converted to farmland, while the initial experiments in growing wheat began in the Palouse region, which previously had been the domain of cattle and sheep ranching. When those trials proved more than successful, a minor land rush quickly filled the Palouse region with farmers during the 1880s. The simultaneous proliferation of railroads only increased the rapid settlement of the Palouse. By 1890, nearly all the Palouse lands had been taken up and converted to wheat farming. Unlike the Walla Walla country, which was solidly anchored on the city of Walla Walla, the Palouse region saw the rise of at least 4 centers, all within several miles of each other: Colfax, Palouse, Pullman, and on the Idaho side, Moscow. These 4 centers, along with at least 10 lesser ones, resulted in a diffuse urban pattern relative to the centralized Walla Walla County. Cities along the borders of the Palouse, and by some definitions included within it, include Lewiston, Idaho, serving the Camas Prairie farmlands, Ritzville, serving the eastern edge of the Big Bend country, and Spokane, the region's major urban hub. So dominant was Spokane's position that it became known as the capital of the Inland Empire, including all the wheat-producing regions, the local mining districts, and lumber-producing forests. Spokane also served as the region's main railroad and transportation hub. By 1910, although local terms like Palouse, Walla Walla Country, Big Bend, Umatilla Country, and Camas Prairie continued to be common, many people of the region began to regard themselves as living in the Inland Empire, the Wheat Belt, the Columbia Basin, or simply eastern Washington, Oregon, or North Idaho. Geology. The peculiar and picturesque Loess Hills which characterize the Palouse Prairie are underlain by wind-blown sediments of the Palouse Loess that covers the surface of over 50,000 square kilometers on the Columbia Plateau in southeastern Washington, western Idaho, and northeastern Oregon. The Palouse Loess forms a fine-grained mantle of variable thickness that lies upon either the Miocene Columbia River basalt group, non-glacial Pliocene fluvial sediments of the Ringgold Formation, or Pleistocene glacial outburst flood sediments that are known informally as the Hanford Formation. At its thickest, the Palouse Loess is up to 75 meters thick. It consists of multiple layers of loess separated by multiple well-defined calcrete paleosols and erosional unconformities. The degree of development of individual layers of calcrete together with thermoluminescence and optically stimulated luminescence dating of the loess indicate that each calcrete layer represents a period of thousands to tens of thousands of years of non-deposition, weathering and soil development that occurred between episodic periods of loess deposition. A consistent sequence of normal-reverse normal polarity signatures demonstrates that the older layers of loess accumulated between 2 and 1 million years ago. Detailed optically stimulated luminescence dating has shown that the uppermost layer of Palouse Loess accumulated between 15,000 years ago and modern times, and the layer of loess underlying it accumulated episodically between about 77,000 and 16,000 years ago. Regional trends in the distribution, thickness, texture, and overall composition of the Palouse Loess indicate that it largely consists of the wind-blown sediments eroded from fine-grained deposits of the Hanford Formation that were periodically deposited by repeated Missoula floods within the Eureka Flats area. Although superficially resembling sand or other types of dunes, the Loess Hills of the Palouse are of far different origin. Internally, they lack any evidence of cross-bedding or erosion of interbedded layers of loess and calcrete that characterize dunes formed by moving currents. Instead, these hills consist of alternating layers of loess and calcrete that are more or less concordant with the modern surface of these hills. This layering demonstrates that the Palouse Hills loess accumulated from the airfall of wind silt from suspension. In addition, the ubiquitous homogenization of the loess by innumerable plant roots and insect burrows as it accumulated further supports the conclusion drawn from numerous thermoluminescence and optically stimulated luminescence dates that individual layers of loess accumulated over an extended period of time in terms of thousands of years. Finally, the calcrete horsens are paleosols that represent the periodic cessation of loess accumulation for periods of thousands of years during which they formed within the surface of a loess layer. Farming. Early farming was extremely labor-intensive and relied heavily on human and horsepower. An organized harvesting, threshing team in the 1920s required 120 men and 320 mules and horses. Teams moved from farm to farm as the crops ripened. By this point, the combine had been invented and was in use, but few farmers had enough horses to pull such a machine, which required a crew of 40 horses and 6 men to operate on level ground. Because of this, use of combines on the Palouse lagged behind use in other farming communities in the United States. It was only when the Idaho Harvester Company in Moscow began to manufacture a smaller machine that combine harvesting became feasible. By 1930, 90% of all Palouse wheat was harvested using combines. The next step in mechanization was development of the tractor. As with the combines, the first steam engine and gasoline-powered tractors were too heavy and awkward for use on the steep Palouse hills. The smaller, general-use tractors introduced in the 1920s were only marginally used. As a result, by 1930, only 20% of Palouse farmers used tractors. Today, the Palouse region is the most important lentil-growing region in the USA. Environment. Once an extensive prairie composed of mid-length perennial grasses such as blue bunch wheatgrass and Idaho fescue. Today virtually all of the Palouse prairie is planted in agricultural crops. The native prairie is one of the most endangered ecosystems in the United States, as only a little over 1% of the original prairie still exists. People have taken the toll on wildlife. Birds and small mammals, once abundant, are now few. The intensive roadbed-to-roadbed farming currently practiced across the Palouse leaves few fences and fewer fenceros. Many intermittent streams have been plowed over. Many perennial streams with large wet meadows adjacent to them are now intermittent or deeply incised. Riparian areas offer breeding habitat for a greater diversity of birds than any other habitat in the U.S. Loss of trees and shrubs along stream corridors means fewer birds and eventually fewer species. The majority of riparian areas have been lost across the bioregion. Lately, conversion of agricultural lands to suburban homesites on large plots invites a new suite of biodiversity onto the Palouse prairie. University of Idaho wildlife professor J. Ratty documented changes in bird community composition over a 10-year period as he converted a wheat field into a suburban wildlife refuge. As of 1991, his 15-acre yard attracted 86 species of birds, an increase from 18. Intensification of agriculture has affected both water quantity and quality. Agriculture has changed the hydrograph, increasing peak runoff flows and shortening the length of runoff. The result is more intense erosion and loss of perennial prairie streams. As early as the 1930s, soil scientists were noting significant downcutting of regional rivers and expansion of channel width. Higher, faster runoff caused streams to downcut quickly, effectively lowering the water table in immediately adjacent meadows. On the South Palouse River, this process was so efficient that by 1900 farming was possible where it had been too wet previously. Replacement of perennial grasses with annual crops resulted in more overland flow and less infiltration, which translates at a watershed level to higher peak flows that subside more quickly than in the past. Once perennial prairie streams are now often dry by midsummer. This has undoubtedly influenced the amphibious and aquatic species. As population grew, towns and cities appeared, changing the complexion of the area. By 1910, there were 22,000 people scattered in 30 communities across the Palouse prairie. Crop production increased dramatically after the introduction of fertilizer following World War II. Since 1900, 94% of the grasslands and 97% of the wetlands in the Palouse ecoregion have been converted to crop, hay, or pasture lands. Approximately 63% of the lands in forest cover in 1900 are still forested, 9% are grass, and 7% are regenerating forestlands or shrublands. The remaining 21% of previously forested lands have been converted to agriculture or urban areas. The impacts of domestic grazers on the grasslands of the Palouse and Camas prairies was transitory because much of the areas were rapidly converted to agriculture. However, the canyonlands of the Snake and Clearwater rivers and the tributaries with the much shallower soils, steep topography, and hotter dry climate, were largely unsuitable for crop production and were consequently used for a much longer period by grazing domestic animals. Their intense grazing and other disturbances have resulted in irreversible changes, with the native grasses largely replaced by annual grasses of the genus Bromus and noxious weeds, particularly from the genus Santoria. The highly competitive plants of both of these genera evolved under similar climatic regimes in Eurasia and were introduced to the U.S. in the late 19th century, with the adoption of no-till farming practices in the Palouse region in the early 2000s. The negative environmental impact of agriculture has visibly decreased. Fires. While there is some debate over how frequently the Palouse prairie burned historically, there is consensus that fires are generally less frequent today than in the past, primarily due to fire suppression, construction of roads and conversion of grass and forest to cropland. Historians recount lightning-ignited fires burning in the pine fringes bordering the prairies in late autumn, but the extent to which forest fires spread into the prairie of the converse is not known. Some fire ecologists believe the Nez Perce burned the Palouse and Camas prairies to encourage growth of camas, but there is little historical record to solve the mystery. European American settlers used fire to clear land for settlement and grazing until the 1930s. Since then, forest fires have become less common. One result has been increasing tree density on forested lands and encroachment of shrubs and trees into previously open areas. Consequently, when fires occur in the forest, they are more likely to result in mixed severity as stand-replacing events. In fiction, the Patriots novel series by James Wesley Rawls, the movie Smoke Signals was filmed on the Coeur d'Alene Reservation in Pullman, Idaho, at the north end of the Palouse. Many outdoor scenes for the movie toys were filmed on the Palouse, in the area of Rosalia, Washington. Part of Neal Stephenson's Cryptonomicon takes place in Whitman County, Washington. Josie Poe, Palouse, Washington 1943 by Kathleen Dewey is set entirely in the town of Palouse.